Hello everyone, it's Mrs. Meerman. I'm going to be walking you through, we're starting a brand new chapter, we're starting 10.1. So if you would like, I'm going to go through some examples and then afterwards you can try the on your own problems in your textbook and you can pause the video and I'll show you the answers at the very end for those on your own problems. So in your textbook, it's on page 412. So let's get started. I'm going to share my screen with you so you can kind of see what we're doing. In chapter 10 is all about exponents and scientific notation. So what we're doing today may look a little bit familiar to you, especially because we've been working with squaring things in the last chapter when we did square roots. You kind of have that understanding of, for example, if I take a number 5 and I square it, I know that that's repeated multiplication. So that means 5 to the second power is 5 times 5. Or if I were to take 4 to the third power, I know that's 4 times 4 times 4. Okay, so what you're going to be doing in this specific lesson is you're going to be writing expressions using integer exponents. And you're also going to be evaluating the expressions involving integer exponents. So again, this is on page 412. For those of you who have your textbook, then you can go through and follow along. You'll notice in these examples are different than the examples in your textbook, just so that we could provide you more problems to work through before you get started on the homework. So in the very beginning, let's kind of look through some vocabulary. Here we have our base. Our base is always our bottom number, our biggest number. We have our exponent, which you can see right here. And our exponent is going to tell our base how many times it's going to multiply by itself. So you can see this total parentheses 1/2 to the 5th power is repeated multiplication. So what that really means is 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Let's go ahead and try some of these problems. I would recommend that you have a paper or pencil and you're doing these problems as we go through them. So in example 1, you're going to write each product using exponents. So in this first one, the first thing you're going to do is look and see what's being repeated. And you can see here the 7 is being repeated. So the 7 is going to be our base. How many times is it being repeated? 1, 2, 3, 4, 5. Because it's being multiplied by itself 5 times, we're going to have 5 be our exponent. So you can write this 7 times 7 times 7 times 7 times 7 as 7 to the 5th power, or you can write it as parentheses 7 to the 5th power. We're going to talk about the importance of parentheses in a little bit once we get into example 2. So to start though, you can write it in either this form or this form. Let's go in part B. Notice 7 is being repeated, so 7 is going to be our base, and it's being repeated 3 times. So it's being multiplied by itself 3 times, so 3 is our exponent. We can write it like this, or we can write it as parentheses 7 to the 3rd power. Let's look at the next one. The next one is dealing with pi and the variable r. So in this case, we're going to have 2 bases. We're going to have a base of pi and we're going to have a base of r. Now I'm going to look at them separately and see that pi is being repeated by multiplying by itself twice. So I'm going to have pi to the 2nd power times, notice r is being multiplied by itself 3 times. So r is my base with my exponent of 3. I can write it like this with the multiplication symbol in the middle, or you can just write it as pi to the 2nd power, r to the 3rd power. Now let's look at part D. This one is a fraction with 1/2 times 1/2 times 1/2. So many of you are going to just want to write it like this. This would not be correct because parentheses is like a big hug. Okay, parentheses is going to hug everything inside together. Notice 1 is being repeated by multiplication 3 times, and 2 is also being repeated by multiplying by itself 3 times. If I just write it like this, I'm going to show you what that would be. This would be like saying 1 times 1 times 1 times 2. And notice when you do that, you get an answer of 1/2. That's not correct, because if I actually multiply this out, and remember when you multiply fractions, you go straight across. 1 times 1 times 1 is 1, and 2 times 2 times 2, well, 2 times 2 is 4, times 2 is 8. Did we get the same answer here? No. So we want to put parentheses in here, because what that does is it takes 3 and it's going to have a 1 to the 3rd power over 2 to the 3rd power. So you really want to make sure when you see that fraction that you put it in parentheses, so that power is taking everything inside that parentheses, both the numerator and the denominator. So let's look at that idea of parentheses a little bit more. And I think after we go through this example, it may make a little bit more sense. We're going to evaluate this expression. So in other words, we want to get, when it says evaluate, you're going to get some type of number at the end. When you see this, again, think of parentheses. And actually, when you go up and hug someone, you do this with your arms, and you can kind of see, they kind of make a parentheses. So you're hugging. If I go up and hug 4 people, I want to make sure my hug gets to all 4 people, okay? So in this case, when you have -2 in parentheses, this 4 is going to everything inside the parentheses. So it's going to repeat as doing -2 times -2 times -2 times -2. So when you multiply that, a -2 times a -2 times a -2 times a -2, you get 16. Notice in this next piece, I don't have parentheses, okay? So what that means is 4 is only going to the base of 2. So 2 is the only thing that's being repeated. I'm going to keep this negative in front, and I'm going to do 2 times 2 times 2 times 2. And when you do this, a -2 times a 2 is -4, times a -2 is -8, times a -2 is -16. So -2 times 2, I'll repeat that because I think I said it wrong, is -4. You multiply that by 2, that gives you -8. Multiply that by 2, you get the -16. So as you can see here, there's 2 different answers. 16 is different than -16, and the difference is the parentheses. Another thing that you can think of -2 to the 4th is that it is the opposite of 2 to the 4th. So if you do 2 to the 4th and you're like, oh, well, that's 16. Well, what's the opposite of 16? It's -16. So you can think of it in 2 different ways. But parentheses plays a huge role. So make sure you pay close attention to those in those problems. Example 3, you're going to evaluate each expression. So again, you're going to try to get this expression to one answer. And a lot of you might want to just put it all in your calculator and be done with it. Well, remember, your calculator is only as smart as the buttons that you push in it. So what I recommend is that you go step by step. So the first thing I'm going to do, and you can always remember PEMDAS, right? You're going to focus on the exponent first. Notice I don't have any parentheses, so I'm going to go right to exponents. So 3 to the 4th power. So let me show you how to do 3 to the 4th power on your calculator. You're going to do 3, and then you have the caret button raised to the 4th power. And you get 81. So I'm going to rewrite this as 3 plus 2 times 81. Now, in our order of operations, what do you need to do next? Correct. You need to multiply. So in this next thing, I'm going to multiply 2 times 81. And when you do that, 2 times 81 is 162. Now, finally, you can see the only thing that you're left with here is addition. So when you add 3 plus 162, you get 165, and that is your answer. Trust me on this, you will be more accurate if you do step by step as I just showed you. If you want to pause this video and try problem part B and C, go ahead and check your answer when you're done. If you're still not sure or want to keep going, then go ahead and just keep going with me. So notice in this first part, in this part B, we have 3 to the third, and then we have this 8 squared. They're both exponents, so I'm going to first figure out what 3 to the third is. And if I do this on my calculator, 3 raised to the third is 27, so I'm going to record that. I'm going to still keep the subtraction symbol that's in between them. And then 8 squared, 8 times 8 is 64. I'm going to do 64. And then I have divided by 2. So when you see this, what is the next order of operations that I'm going to do? I'm not going to do 27 minus 64 because I have this division right here. Okay, so I'm going to take negative 64 divided by 2. And what do you get when you do negative 64 divided by 2? Negative 32. So I write it right below it and move down my 27. And 27 minus 32 is negative 5. So your answer to part B would be negative 5. Notice you're doing each part and going vertically in order to help solve it. Okay, in this last one, you want to first look and say, okay, where do I begin? Notice these symbols mean the absolute value. Okay, so the absolute value is the distance away from 0. So we're going to apply that at the very end. These are not parentheses. Okay, these vertical lines, when they are like this, mean absolute value. So in looking at this, I'm going to first focus on the division part because division comes before subtraction, and please excuse my dear Aunt Sally. So to do this, I'm going to just copy down what I'm not going to change, and I have negative 82 divided by 2. When you do negative 82 divided by 2, you get negative 41. Okay? I'm not going to focus on the absolute value sign yet. I still need to subtract 33 minus 41. So when you take 33 minus 41, you get negative 8. And here I have the absolute value. So what's the absolute value of negative 8? Is 8. Let's now look at example 4. Prime factorization of 200 as a power. Prime factorization is breaking it down so that the only thing you're left with is numbers that you can then turn into exponential. So looking at this, I'm going to first ask myself, what two numbers when multiplied together give me 200? There's many different possibilities, but I'm going to write 100 times 2. Now look at this right here where it says prime number. Think of this as a trail, okay? The minute you hit a prime number, I want you to circle it. That is the end point for that side. But notice 100 is not a prime number. So because 100 is not a prime number, I need to break that number up. So ask yourself, what two numbers when multiplied together give you 100? What comes to mind right away is 10 times 10. So I'm going to do 10 times 10. Notice 10 is not a prime number, so I have to keep going. The only two numbers that can multiply together to get you 10 is 2 and 5, which are both prime numbers. So I'm going to circle all of those. So in order to write the prime factorization of 200 as a power, you're going to look and say, okay, I have 3 2's right here. So I'm going to write that as 2 times 2 times 2. And I have 2 5's, which I'm going to multiply it 5 times 5. Now we want to write this in exponential notation. So 2 times 2 times 2, we're going to write as 2 to the third power, times 5 times 5 is 5 to the second power. And that's our answer. Finally, let's look at example 5. Here it says you take a piece of rope that is 5 feet long. You cut it in half. You do this 3 more times. What is the length of the rope? So for example, what this means is, let's say I have my rope, which is 5 feet long. You're going to cut it in half one time. Then you're going to cut it in half another time, and finally one more time. Okay? In order to figure out what is the length of the rope, okay, you need to first figure out, say, okay, I have one that is 5 feet. That was my total. And I'm trying to figure out how big is it once I fold all of the folds. Okay, so I'm going to take 5, and it says you cut it in half. So to cut it by half, some of you might think, oh, well, you divide it by 2. What's the same as dividing by 2? Multiplying it by 1/2. Okay, so there's a half. Then we're going to do this 3 more times. So we're going to do times 1/2, times 1/2, times 1/2. So for a total of how many 1/2s? 4 of them. So I'm going to rewrite this as 5 times 1/2 to the 4th power. Would that be correct? No, because remember, this 4 is only going to the numerator. So if I want it to go to the denominator, I have to put it in parentheses. So when you do this and you multiply it, okay, you can actually kind of multiply it all the way. If I go back to this one, would be 5 over 16. So after you take a 5-foot rope and you cut it in half, and half, and half, and half, and half, your length of that little piece is going to be 5/16 feet. Right now would be a good time to go ahead and pause this video, and I want you to try the 7 on your own problems in the textbook. Once you try them, I'm going to come back to the video and I'm going to show you what those answers are. After you check your answers, then you're ready to try the assignment on the Big Ideas website. Don't forget to submit once you finish that assignment. Also, you'll notice on the document for this week that there is a checklist. Make sure you're checking that off to make sure at the end of the week that you did all of the assignments. This is the first week that we're going to be giving you credit in Gradebook, and in order to receive credit, you must complete all of the assignments and submit them. If you do not submit them, then we cannot give you credit. So go ahead and pause this video, and when you come back, the answers will be there. So now that you've tried the on your own answers, here are the answers to those 7 problems. We hope you're doing well. Please reach out to your teachers if you have any questions regarding this lesson. Have a great day.